Okay, it's good.
Okay. Yeah, it looks like we're online.
Great.
Great. So, hello, everybody. This is the September meetup 2022 of the Jacksonville Java User Group. And this is still a virtual meeting. We hope in the future to have hybrid meetings. And we have Mary G. I'm afraid to say I'm Eyal
No
W.
problem.
and she's Mary G.
No problem. That works.
Great to have Mary here. She actually was once in Jacksonville at the JAG in person,
That's right.
uh, and it's always great. She's a good friend, and it's always great to meet you, Mary, and have you as a speaker.
Thank you.
So, Mary, I'm going, and Mary also is the leader of the Chicago JAG, which is a very large Java user group with quite a legacy.
Thank
So
you.
I'll let Mary introduce herself some more and do her presentation. Anybody that has questions, you can use the questions and answers or just a regular chat. You can use emojis at the bottom of the screen for reactions. And that's it, I think. So I'm going to hide myself. Let's see how I do this.
Okay. Okay. Thank you. Thank you, Eyal, again for the introduction. Thank you to all of you, I guess, in the audience that we just met one another. So thank you for taking your time out, in the evening and come to hear me talk. And again, thank you so much for the invitation, Eyal. I'm just very happy. Although I would prefer to be in Jacksonville, I think it's fun too. You're near the beach, near the ocean. So, but yeah. So let me start, and I'll share my slides. Okay, here we go. So I think everybody can see it, right? Okay, good. So if you can't, let me know, then I will adjust it too. So, okay, so you've come to my talk, and I'm going to be talking about event streaming and processing with Apache Pulsar. And if you can let me know if you have heard of Apache Pulsar before this session, if you can let me know maybe in the chat, just kind of let me know. I would just like to know because for one thing, Apache Pulsar is relatively new. And then also let me know if you are already working with some streaming platforms such as Kafka. I think Kafka has become the household standard. And so, yeah, and Andres, yeah, thank you. Yeah, so you have not heard. So yes, so Apache Pulsar functions kind of like Apache Kafka, except it is more of a cloud native ready streaming platform. And that's something that I will introduce you to in this session. So yeah, there was a Pulsar presentation in DevNexus, really? Yeah. Oh, I think I know. That's from Tim Span, and he works for Stream Native. So I will kind of mention a little bit. Stream Native, in fact, is the company, the startup company that's kind of composed of or founded by the original creator of Apache Pulsar. So they kind of continue on with their tradition, and that's what they do is Apache Pulsar, but they do it so it's a kind of commercial way, right? So that's what it is. But for DataStax, actually, and just to give you an idea too, DataStax, the flagship product is Cassandra. So maybe some of you have probably all of you have heard of NoSQL database called Cassandra. So Apache Cassandra. So that's what DataStax is kind of more well known for. And we have a cloud platform for the managed Cassandra in the cloud called Astra. And then now with Astra DB that we also added in Astra streaming. So that's actually Pulsar underneath the hood. And that's what it is. So and Pulsar, too, is a relatively new kind of open source being adopted by DataStax. And so I joined about 6 months ago at DataStax. So yeah, so with that, let me start. So again, I already mentioned to you, I'm a streaming developer advocate at DataStax. And this is my Twitter handle if you like to follow me. And I also have other kind of way you can stay connected with me too. But first of all, if you like to follow along and would like to take a look at the slide deck, and it can be accessed here. So if you want to quickly scan that, I'll just assuming you need a couple seconds. If you want to scan it and follow along, you're welcome to. And if you miss, don't worry about it. I can share this link again with Eyal, and then with the Jacksonville Jug, you can also get it that way too. So okay, so that's that. And so let me introduce myself. I'm doing developer advocacy at DataStax. And so I can just spend 3 seconds by talking about advocacy. So for advocacy, I'm not a full-time developer anymore, although I have to say too over here, the last paragraph actually described myself. I was actually a software engineer, a developer too, for over 20 years in the Java space, right? Since like year 2000, I started working with Java. Previous to that, I was actually working with C and Unix, and then I switched to Java in 2000. And then since then, I've always been working with Java one way or the other. And then in the 4 years ago, I joined IBM as a developer advocate. So the last time I visited with Jacksonville Java Users Group, that was in 2019. At that time, I was a relatively new advocate at IBM. I was with their Java advocacy team. And so what advocates do is that we go out and do outreach work, meaning, we kind of like educational too. We're spreading the knowledge. We're sharing the information with audience. And most of your audience, we're all developers. That's why we're called developer advocates, because we speak your language and trying to also explain to you what this software does, right? So, okay, so Eyal already introduced me to that. I'm actually originally from Chicago, or actually not very originally, but I am from Chicago, I should say right now. I actually was born and raised in Hong Kong, and then moved to the U.S. About many years ago, and so have been living in Chicago for about 16 years now so far. I'm also a Java champion and also the president of the Chicago Java Users Group. And I'd like to invite you to join our meetups. So if you go to meetup.com and search for Chicago Java Users Group, you can find our group. And right now too, we're taking a bit of a break because also we are having an in-person conference in just 10 days, and that's called jconf.dev Chicago. So if you're in Chicago, you want to join us, we still have tickets available, and we have plenty of great speakers too and great sessions too. So just so you know. Okay, so that's about me and my area. I've been working again, not just with Java, but there's event-driven, reactive systems, open source, and cloud-enabled distributed systems. I'm always interested in distributed systems, right? These are dealing with message communications, that type. So, okay, and then on the left side too is that, information about how you can stay in touch with me, follow me on Twitter, or get connected with me on LinkedIn. Or also I have a Twitch session every Wednesday, or for this week, I'll actually be doing it tomorrow, Thursday. And then I also have a Discord server if you want to stay connected with me and message with me too. Okay, so this is another kind of a quick description for my current company, DataStax, that describe me, right? All of the things I'm doing. I'm kind of first and foremost, I feel like I'm a passionate advocate because I like going to talk about things and sharing of knowledge with developers like yourself. So, okay, so let me start, right? So event messaging or event streaming and processing, or sometimes I also call it event messaging too. These are like all seem to be terms that have been kind of being talked or discussed together. But first of all, before I get into all the Apache Pulsar, all of these things, I thought let me spend a few minutes just kind of giving you some basic or clarify the concepts, right, of computing events. And essentially two, like event streaming, event processing, complex event processing, event-driven versus message-driven messaging. Then there's PubSub, right? Essentially the processing semantics. You can do publish, subscribe, or doing message queuing. And then from there, I'll talk about why do we want to do event streaming and how can it improve your systems. And then I'll introduce to you Apache Pulsar and also its dependency on Apache Zookeeper and Apache Bookkeeper. And then I'll highlight a couple of the Apache Pulsar developer features too. And then also, again, like why Pulsar, right, among any other choices that you have, for example, like Apache Kafka. So essentially, I call it like Pulsar is extending what Apache Kafka can do. You can do more now with Pulsar in the cloud. So now let me start, right? Many facets of computing events. So what is an event, right? What is it that we're trying to deal with? I want to kind of first point out that if you are new to doing event kind of driven programming, right? Event driven systems, they are a bit different, right? Different than most of us, how we started programming, kind of in the more synchronous fashion, in the more blocking and kind of request response style. Events is very different because it deals with a synchronous style of processing. So it's very different. It's a kind of it requires a bit of a shift in how we think about solving problems. But what is an event, right? So generically speaking, it's interesting. I thought it's important to kind of understand what an event is. So the thing is, to me, right, I find it fascinating because I think events are all around us. And it's interesting too. When I actually applied to a conference in the past, and or not just a conference, many conferences, when I submit my proposals and I submit a topic that talks about event, I actually got asked by a one of the organizers, right? And that person actually is not from the computing kind of a background, computer background. And then she was asking me, "Is like, you mean events are like musical events, like a concert, right?" So I feel like, oh yeah, that's what essentially events means. So in the computing sense, right? And especially if you try to describe it, I would say, okay, first of all, in a dictionary, Merriam-Webster.com, essentially it says event is something that just happens, right? An occurrence of something. So in the computing side of things, in the more scientific way, if you bring in the fourth description in here on this slide, it's from the theory of relativity. Relativity. So it's basically an event is like the fundamental entity, right? If you kind of have to think of it, right? Things are abstract; you can't actually touch it. But if you think of it, a concept is that it's a fundamental entity of the observed physical reality that's represented by a point designated by three coordinates of place. So if you are mathematically inclined, it's the XYZ coordinate. So if you think of space, right, there's just a point in the space is represented by XYZ coordinate. But for events too, it's more interesting because it takes in the time component, which actually is the space-time continuum, right? It's postulated by the theory of relativity. So it's essentially four dimensions, X, Y, Z, and also your time. So that kind of constitute an event. And then in computing too, because things keep changing, right? The time keeps moving. So at any given point in time, your events will keep changing state. And that's the thing in computers that we're trying to capture the state of the changing nature of your data points in time. And not only that, when it comes to like event streaming processing, it gets to be even more complicated. Now, it's simple enough if we're just trying to do something like one event and then you see, you want to publish some event data, try to subscribe to it, right? Look at the messages. It's kind of simple enough. In reality, though, right? That's why I'm interested in doing events is that we're dealing with complex events kind of a situation. We're kind of observing, many things are happening all at once and at different times, and you're tracking all of these data in space and time. And so events, again, refer to each data point on the system. And then the stream is basically refers to the ongoing delivery of those events. And that's what we're trying to capture, those streams. And then a series of events can then be referred to as streaming data or data streams, right? So streaming too can also be referring to like media streaming, like, audio and video. Although I have to kind of a bit of a word of caution is that I realized at first too, I thought we can use Pulsar to do audio video streaming, but in fact, it actually can't because of the nature of video and media streaming is that those data, they do actually require a more synchronous way of processing because you do need to render all these kind of voice or media like differently when you try to produce the output. Then again, going back is that this streaming that we're trying to do is more dealing with data, with systems, and not with media type of streaming. But the thing is, though, the idea is the same. These are streaming data or data streams is ongoing delivery of these events in space and time. And that's what it is. So, okay. So you might be saying that, well, that's enough of this theory. So let's move on. And the thing is that interests us and makes the most sense of why we want to do event processing. To me, too, I think it mimics the real human conditions, right? Because we don't, just think of the fact that when you first started programming, you're doing things the synchronous way. Things are like, you want to issue a command. For example, I learned basic, right, visual basic programming. So you're doing things like, okay, you take the input and then you want to do some processing, and you say, in your line, you say go to, right? All these things are very synchronous, right? The way you have to wait, you issue a request, you have to wait for the answer, wait for things to be processed, and then you get the result back. It's kind of pretty kind of rigid, so to speak, and it doesn't mimic the real life human beings, how we interact. We do things asynchronously. When we call people, we want to be able to talk at the same time or talk different times, all these things. Those are really mimicking the real life scenario, and that's represented by doing things in an event driven way. So okay, so gets to like complex event processing. So complex event processing is basically a set of techniques, right, for capturing and analyzing these streams of data as they arrive. And the purpose is to identify opportunities or threats in real time. So think of the fact that we're doing fraud detection. So you don't want to wait, for something that happens to your bank account. You don't want to wait to be notified. You want to be notified right away. And so that's the goal of doing things in an event driven manner, in event streaming thing, is that you want to be able to kind of analyze the data as it comes, and then kind of identify if there are opportunities, if there's threats in a fraud detection system. So complex event processing essentially enables systems and applications to respond to these events, to the trends, and to the patterns in the data as they happen. And now then, let's kind of turn a bit then into some fundamental basic thing is dealing with the messaging aspect of event kind of driven and message driven messaging. So for event driven, when we talk about event driven system messaging, it's basically we're talking about the sender, right, that sends the messaging and sends out these messages. And basically, the sender doesn't have to worry about who is going to be receiving the messages. It's basically it will send the messaging out, and it depends on a broker that will be helping to deliver the messages. And to whom do you deliver? It's basically are the subscribers, the subscribing clients that are interested in the messages. They will subscribe to the messages of interest to them. And then at the time when the sender sends out the messages, and then the subscriber will receive it, if they are subscribed to that messages. So that's event driven. It's more like, think of it this way: the sender doesn't worry about the address of the receiving client. So think of it this way, right? Event driven is kind of nice in the sense that you can help to scale your system easily too, in that sense. But you do tend to have to rely on a middleman to help you to deliver the messages. So that's event driven. Now, in message driven messaging is that it's like one to one. Sender and receiver, they have to be known to each other. And so when you send the messages, the sender will have to know what address do I send the messages to my receiver. And that's more like message driven messaging. So these are like kind of some differences between the two style of messaging. And now then kind of take a look again, right, about event doing things in the event approach. If we don't do it event driven way, how can we do? It's basically, think of batch processing is sort of like it counter juxtapose the event driven approach. So events are, we're dealing with things that as data, changes in the data, we react to it. And then essentially too, it allows you to have instant kind of results from processing the data. That's event approach. But the other way is basically the opposite way, is batch processing. Now, batch processing is, as we all know, they tend to be, it's been actually in the history of computing for a longer time. Because why? Because we want to gather up changes in the data and then batch it all up and then processing them, in essentially, that's why it's called batch, in bulk, kind of this way too. When you do things, right, batch it up. For example, an employee information system at a company, those things, right, they are kind of systems of record. They are not requiring any kind of immediate kind of notification of any changes to it, or you don't need to act on it right away. If, let's say, you're an employee, you need to update your address, and you can do it, basically update, you send the update over, but the processing will happen at night, for example, because then those are non-urgent data that it can be wait to be processed. And essentially too, then it takes up less time for networking as well, because you batch it all up and they are probably already on the system that you need to process your data. And so it takes up less resources, especially in the middle of the night. Then other systems may be sleeping and it's not processing any kind of instant kind of systems that require intermediate kind of or immediate results. Then you can batch them up and do them at nighttime when your systems are more idle, have more cycles to process them. So okay, so that's that. And now, then let's get into a bit more like event messaging, right? The delivery part, right? And so now let's then talk about streaming. So this is kind of theme of our talk. It's streaming. Very often too, when we talk about streaming, then we think of like PubSub because it allows for data to be kind of an ongoing delivery of these events through your system is PubSub. So in a PubSub system, essentially it represents publishing and subscriber, right? So the publish subscribe is a design architectural pattern. And so the idea is that the publishing client will publish the data. Think of like event-driven type of messaging, right? Publishing, we will send the data over, and to who? It's basically to the broker. So broker is, think of it like a post office. I need to send a bunch of messages out. I don't actually do the actual sending and delivery. I tell the postmaster to do it for me at a post office. So think of the broker is like a postman, a middle person, an agent that takes all your data that you need to deliver, and the publisher will then identify this the data, according, call it like topic, right? You kind of use a topic to identify your data, or sometimes some system call it a channel or routing kind of a router kind of terminology for these data. So then the broker will know how to deliver it. So and then in this case too, then you also need the subscriber client on the other side to subscribe to the topics that are of interest to them. So when publisher publishes the data to a topic, then the broker will deliver it, and then whoever subscribed to it will receive it. If you don't subscribe to it, you don't, right? So in a sense, the subscription part acts as a filter for all the messages that's going through the broker as well. So the nice thing about this kind of system, as you can see, is that PubSub, it actually helps you, it decouples the sender and the receiver. So then if you have tons of messages coming in, it's actually help to scale it very easily, as opposed to if you have things that are direct, one-to-one kind of delivery, then you can easily kind of like jam up your whole delivery kind of thing, because it just doesn't scale as well. So that's the one good thing about doing things streaming way, and your publisher doesn't have to know the address of the receiver, kind of like that. So okay, so that's kind of a quick kind of intro to PubSub. And now the other way is basically, if you don't do PubSub, then there's message queuing. The idea is also the same, is that you do decouple your sender and your receiver, except then your messages goes into a queue. And also too is that in a message queue is that your receiver will kind of, or basically I should say, it enqueues into the system. So whoever is there, the subscriber will then kind of subscribe to the messages, and then and as soon as the messages gets delivered to the receiver, to the subscriber, then the messages will be removed off of the queue, as opposed to a PubSub system. And it also depends on how the vendor, right, designing the PubSub system designs it. But very often too, the messages can be retained, until it's maybe like acknowledged, then it will be removed off of your system. But very often too, message queues is that you get DQ'd and then it will be removed off your system. But PubSub too, you get to retain until, at a certain time, maybe you acknowledge it, then the messages will be removed from your system. So those are kind of the differences. Okay, so now then let's get a bit more into event streaming, right? So, and what is driving this change, right? Event streaming is becoming more and more popular. So basically, again, right, I talk about the fact that you can kind of use this approach to produce like real-time data and helping you to do analysis. So the big advantage of it is that because everything is real time, then it essentially give your customer of your systems a more satisfying experience, right? You get your results right away, kind of like that. The real time part is one big, kind of reasons for using the event driven approach. And then another thing is basically you can also like use this approach of event-driven to build, so to speak, like data pipelines, right? So what are data pipelines? Because we have kind of publish, subscribe. So think of it this way: you basically have publisher publishing the data, and then receiver receiving on the other end. But the receiving end can also become another topic that actually, or actually, I should say, another producer too. And so essentially, you can chain all of the flow of your data in like a chain, right? Think of it like, source and destination. All of these can be chained together to form a huge data pipelines that flow through a different systems. And in the systems like Pulsar is that you can have different kind of clients, even though the broker itself is written in Java, but you can be doing a .NET client. You can work with a Go client, publishing data and then to the broker, and then the subscribing side can be a .NET client, for example, things like that. So it helps you to build your data pipelines very easily. And in data pipeline scenario too, you can also use it to build your artificial intelligence type of applications or machine learning types of systems, right? And also ML ops too. That will be a one big area that can leverage on this approach. Because why? Because in AI and ML systems, and I'm sure Eyal can tell because Eyal, you have written books on AI and ML. So that's a very good candidate use cases for event streaming kind of systems, because at any given point in time you are ingesting data in high frequency, right, in huge volumes, and you want to be able to have it kind of ingest the data quickly and being able to analyze all of these changes very quickly. And not only that, then with the data being ingested, you want to derive some conclusion or analyze your data and then update, have algorithms that update your data model immediately and then be able to deploy it immediately. So think of using an event streaming type of systems that helps you to move through chunks of data through your system really fast, and having it update your data model immediately is actually a really, really kind of a good plus right in there. Although in reality, from what I've done some research, I think a lot of AI and ML systems may not be leveraging on this yet. And I think because I've been told that the amount of data is in terabytes, for example, something like that, and maybe the streaming systems aren't able to handle it. But the thing is, I think these event streaming systems are becoming more and more commonplace and becoming more capable, and also leveraging on the hardware changes too. So I think at some point it has to start to use more of this event streaming approach to do AI and ML type of applications too. Okay, and then one more thing too about event streaming system is that it helps with scalability. As I kind of described, right, your publisher subscriber are being decoupled, and basically it helps in scaling it very easily too. So you can also increase the number of brokers to handle all of your messages. There are also kind of concepts of topics being partitioned into different broker. You can have a topic essentially being handled by multiple brokers too, because the goal of such is to increase the throughput of your message delivery. So as you can see, if you need to, in your cloud environment, you need to scale it up. You have more, nodes and in your cluster, and all of these things. And basically, it kind of helps to scale up much more easier with this pops up type of approach too. Okay, so just a summary too, again, right, for why event streaming is basically it helps you to watch for events with the system or application, and you only subscribe on the subscribing side, you subscribe to topics to see only certain event types that are of interest to you. And then it helps to make decisions on data in real time and not after the event. And also essentially help to ingest high frequency of messages with low latency too, essentially. So very responsive. So now then let me introduce to you Apache Pulsar. And what is Apache Pulsar? It is an open source project, right? And it was originally created by Yahoo back in the early 2010s. And at that time, the cloud was starting to become kind of the thing, right? And so at that time also too, Apache Kafka already has been in existence in its earlier versions. But the thing is with Kafka is that it's essentially being designed and focuses on the distributed messaging part. So Kafka too also handles the storage of all of these log messages and everything. So it's less having an awareness of cloud native, right, at that time. So that's how Kafka was designed. But then Yahoo too was, as we all know, Yahoo is dealing with all kinds of services. Yahoo finances, Yahoo, market, whatever you name it, right? That Yahoo has all of these features or services, deals with tons of data in the cloud too, and they are early adopters of the cloud. And they realized that if they needed to increase the number of clusters, if you use some older style of message queues, they just don't scale as well. And you have to do a lot of manual work to essentially kind of scale up your whole, ecosystem of your messaging and all, kind of servers and all that. So they kind of became aware of that problem. It needs basically a better system to handle event messaging in a cloud kind of truly like native manner. So then they started working on Pulsar, and they designed Pulsar. And then eventually, too, in 2016, they donated it to, contributed to Apache Software Foundation. And within like less than 2 years, essentially 2018, it became a top level project because a lot more systems and companies are recognizing that they need to also kind of run event messaging system in a cloud native environment. So Pulsar kind of became the first of its kind to be able to kind of run kind of natively in the cloud environment. So the design is very cloud native design. It's all cluster based, and also it's multi-tenancy too. And also too, the thing is, as I talk about, right, you decouple the sender and the receiver. So the client APIs are actually quite, not too difficult. It's basically you can do, like in Pulsar case, you can have Java, C Sharp, Python, and Go. These are kind of already supported. And there are also community contributions to different client types, such as like Ruby, such as Scala. If you're into that, there are also support for that. But you need to kind of look into the community. There are people also supporting that for you. And one kind of really outstanding kind of design of Pulsar is that, as we know, right, when we do asynchronous type of messaging, we're dealing with messages passes through, your system, your broker, in kind of thousands, or if not, 10,000 or petabytes of data. But the thing with Pulsar's design is that it separates out the compute part. So all the broker, all of the dealing with the pubs up, the actual kind of brokering off all your messages, it only focuses on that. Because on the storage part of all of these log messages, right, it gets quite complex. As you can see, so many messages, right? You need to guarantee that it's being stored correctly. When you write to disk, when you read from it, all of these things, you need to have the cursors to move it back and forth to kind of look through old log messages. So Pulsar decided it's not its job to deal with these huge amounts of log messages. So it delegated to Apache Bookkeeper. So that's another Apache open source project that's kind of focuses on managing all of these chunks of data. Think of it, Bookkeeper is like just an accountant, right, that manages all of these records for you in kind of trillions of data of records, right? It's very efficient too. So it's basically Pulsar separates out the compute and the storage. So think of the fact that if you need to scale it, it's actually becoming a lot easier, because if you add a node, add a cluster to your infrastructure, you basically they scale separately too. They manages all of it. So then as developers, you don't have to worry so much about doing all of these things. How do I actually increase, my kind of my storage, all of these things, because Pulsar already knows how to do it. It coordinates with Bookkeeper to handle that part for you. And then another kind of advantage of Pulsar is that, the thing is with message delivery, they are asynchronous. So you do need to have a way of guaranteeing that the messages gets delivered, kind of safely. So the Pulsar broker has already built in like guarantee message delivery, like the quality of service, all of these, it observes it. So you can actually do not exactly once, but there are also at least once delivery as well. So it guarantees the messages will be delivered to your target. So let's say there's a network problem and your servers go down, your brokers go down, or you have another broker to kind of take over. For example, it guarantees, it has mechanism already that guarantees, don't worry about it. You leave it to us. We'll take care of delivery, and you just rest assured it will be delivered to its intended recipients, right? Whoever subscribes to it. So that's that. And then another advantage of Pulsar is that our features, it's called like serverless functions framework. So think of the fact that you're building your data pipeline, you're reading your data from the source, and it passed through the pipeline, and you want to do some transformation, right, to the data, for example, filter off some data or kind of modify the format however you need. So you can actually use a Pulsar function to do that for you too. And that's actually provides you with the serverless it is a serverless functions framework, I should say. It's very lightweight as well, and it's essentially you don't need to like rely on any other third-party functions library to do the transformation for you. You can simply use Pulsar functions to do it for you. And currently, though, it's supporting only Java client and Go and Python, but there will be additional support of languages too for the Pulsar function framework as well. And then one more thing about Pulsar is that it has what is called like tiered storage offloads. So think of all of your log messages, right? And the thing is, after they are kind of waiting in queue, right, and they become cold, right, they are no longer hot, kind of in hot storage. Pulsar has already built in mechanism to move all of these cold messages to long-term storage too when the data is aging out. So all of these things, Pulsar already has it built in. It's also very flexible. So then as developers, you are less concerned with dealing with this kind of infrastructural thing. And then you can focus on doing your logic, right, for your applications, for your business, rather than dealing with infrastructural concerns. So okay, so I spent enough time on that slide because it was a lot of stuff. But now, again, this is just a quick summary. What is Apache Pulsar? It's a unified distributed messaging and streaming platform. It's open source, right? And it's also cloud native, very much a cloud native built into its DNA. That's what I would call. And then if you kind of take a look at a couple of these kind of what you call like the graphs that I'm showing in here, essentially you can see too the number of GitHub stars have kept increasing. So this is like a little more than a year ago. You can see it just keeps growing. And then the contributors too also increasing. And even active contributors has surpassed that of Kafka, because a lot more people, when they're using Kafka, they realize it just doesn't scale as well. It's just harder to do. You can actually do some of these kind of what you call like like recovery kind of systems, but you have to write a lot of these code yourself or set up all of these kind of backup recovery mechanism yourself. But for Pulsar, it's already built in, so it makes your life a lot easier. And who else is using Pulsar? So as you can see over here, all of these big companies, right, Comcast, Yahoo, Verizon, and all kinds, Splunk, they are also using Pulsar too. There have been like an increasing number of companies interested too in integrating with Pulsar. And Pulsar is different. And let me kind of quickly kind of step through again. So these are the kind of essentially, if I have to think of the components of Pulsar, we have the producer, right, that produces the messages, or the consumer, and you know that consumes the messages. So you write code, as producer or as consumer, and then you rely on the broker to help you. That's a stateless process written in Java that handles incoming messages and message dispatching and communicates with the Pulsar configuration store, and then stores all of the messages in Bookkeeper. It communicates with the Bookkeeper as well. So again, there's Bookkeeper that helps you with the persistent message store. That's Bookkeeper's job. And then Zookeeper is there to help you to manage, your cluster, the metadata, handles coordination of tasks, between all of the clusters and everything. So these are essentially the 5 major components in a Pulsar system. Oops, let me see. Okay. And some of the design principle too about Pulsar, right? So it's a tiered architecture design too. It's a traditional, kind of in a traditional multi-node architecture, as you can see. It supports kind of horizontal scaling very easily. So by horizontal scaling, we're talking about you're adding servers into your infrastructure if you need to expand your system, right? Rather than just adding maybe disk to a server, you're actually adding additional servers, adding an additional cluster. It supports kind of horizontal scaling very easily too. And there's also this idea or concept, right, of topics being partitioned, right? They're partitioned off, being managed by different brokers. And it's basically can be very complex too. But if you do partition topics, Pulsar can already take care of, how do you scale it up and down? If you add another cluster to your system, how do you rebalance all of your topics, that are running on different brokers, on different clusters? As you can see, it gets pretty complicated, but Pulsar already has that built in and manage all this complexity for you. So now think of the advantage of it is that not just rebalancing, the scaling, when you scale it up and down, your partition rebalancing. But the thing is, if you tightly coupled like persistence and message serving, then it can become very hard to do, right? You have to kind of spend time on dealing with the infrastructural side of things. But again, Pulsar kind of separates out the persistence, the storage, right, and also the computing side. So scaling and up and down all of these things is kind of all independently managed and makes it a lot easier to work with too. Okay, so just to kind of quickly summarize, there's this Bookie, right? So this slide just wanted to point out, as you can see, Bookie itself is its own complexity. If you're interested, you can kind of search, Apache Bookkeeper project and read up more on it. And we actually at DataStax, we have committers to the open source, Apache project, Apache Pulsar project, as well as Bookkeeper project too. So Bookie itself too, it manages all of your log messages, and they group them into different segments too. And also it supports this standard called WAL based, and which means like write ahead logging kind of based. So if you are into all of these things, it guarantees fault tolerance and low latency storage service. If you need to fetch it, using Pulsar has this concept of cursor. So unlike, right, if you work with Kafka, you know that it gets complicated because Kafka has different consumer groups, and then you need to do, it manages how do you look up all of the messages in your log, kind of logs, right? So it deals with things using offset, right? If the Kafka offset, as you can see, right, the offset is actually quite hard to work with, and you have to know where things are and then kind of figure out where your offset is and all of these things. But for Pulsar, guess what? We have a flexible cursor too. You can kind of use the cursor, traverse, all of your log messages easier, and it coordinates with the Bookie to fetch the messages that you need. And so with that cursor kind of mechanism, it actually helps. There's also through like what is called like a reader interface, you can actually kind of read your log messages, from the past, for example, much easier too. So and over here too, again, Bookie guarantees your log messages are saved correctly and written to, storage and can be read really fast, all of these things too. So and it has a concept, it's called ledgers. And much like accounting, you have ledgers. That's how it groups all of the log messages into ledgers. And then physically, too, they're segmented off, in their storage, too. Okay, so just a quick summary then. Apache Pulsar is basically the next generation of enterprise messaging and streaming, right? It allows you to do PubSub, allows you to do queuing and streaming, and also the message mediation and enrichment through the use of the Pulsar functions too. Out of the box capabilities will have, cloud and on-premise and hybrid, and also allows for geo-replication, right? And geo-replication is another thing that I will have another slide just quickly to show you. Also multi-region support and data lake integration, working with different like data analysis tool, for example, OLAP, right? Kind of online analysis processing, like real-time analysis system. For example, I recently did a talk with this company called Startree, and they are the ones that actually work with Apache Pinot, which is an analysis online analytic kind of machine. And so they are actually the ones that drive the engine behind LinkedIn, right? You see all of the feeds and all of your quick analysis, who has looked at your profile and all of these things, right? They are actually using Apache Pinot to do it. So they actually are also using Pulsar as the source of data too. So we kind of closely work hand in hand with other types of analytical type of systems too. Okay, so this one I won't kind of go over in here, but I wanted to point out in here is that some key differentiator about Pulsar, right? So again, I already talked, bring it up. I want to lay it out again. Separation between compute and storage. So this really helps, right? Because it helps with horizontal scaling. Think of the fact that Pulsar can focus on the broker on the messaging side, and then the compute side, and so the storage is offload to Bookkeeper to manage all of the kind of log messages for you. So it makes the scaling a lot more easier. And then the next thing is about geo-replication, as I just now mentioned. So in some companies, for example, you have data centers that are scattered all over the world in different geo-regions, right? You can replicate your data between different data centers. However, for example, the nice thing about this is that, for example, over here, I talk about flexible messaging replication mode and patterns. You can have synchronous kind of way of replication or doing asynchronous style. And it has also what is called active, meaning that you can keep all of them running at the same time when you are doing a replication to like active or active passive. And you can also do selective message replication. So for example, right, in Europe, and they have, for example, GDPR, which is like a data privacy kind of rule, right, the policy. So for example, you have a global company, you have data center in Europe and then in the US or South America, all of these. And so you want to replicate your data, but you can also do selective message replication. So for example, GDPR data, you don't want to replicate outside of your region, right? That type of stuff. So you can easily kind of use Pulsar's available configuration mechanism to kind of do all of these message selection when you replicate the data. So it gets to be quite easy too. It takes into account that you have the need to do selective replication between different regions. Okay, another differentiator is about multi-tenancy. So with your data to all of these messages, you can essentially group, in within a cluster, you can basically divide up into different what is called like tenants, right? It's like in an apartment building, you have different tenants in different apartment unit. Think of it like that. So each independent unit, it has self-sufficient, kind of think of it like that. So in Pulsar's terminology, you have your cluster, then you have your tenant, and within that particular tenant, it doesn't know what the other tenants are doing, but you manage all of your data within your own tenant, that particular unit. So for example, like here is an example of a company. You have finance department has its own tenant, marketing, and then product division. So they all get the messages gets kind of all managed within its own tenant. So it makes it a lot easier to handle all of these messages too, between the different kind of demarcation of all of your message boundary too. So and then one more thing too about Pulsar is that it's also like very flexible, the message processing model. On the subscription side, right, you can have four modes, one of four modes when you deliver your messages in that subscription. You can specify it as an exclusive mode. Exclusive means that you only specify one consumer in that subscription. So in that case, then you are effectively kind of turning that particular subscription, that particular producer to consumer into like a queuing kind of functionality. Remember, message queues, if we're talking about sender and receiver, they need to know each other, although they don't quite know each other's kind of address, so to speak, but they are dedicated to one another. So that's kind of turning into sort of a message queuing type, one-to-one, point-to-point kind of delivery. In this case, it's an exclusive mode. Now, there's also another mode, it's called failover. So you can have two consumers specified. So essentially, you can have the primary consumer. So if the primary consumer, for some reason, is disconnected, whatever it isn't working, then you have the backup, kind of the secondary consumer, kind of take over. So that's called a failover type of subscription mode that you can specify in your subscription. And then the third kind is a shared mode. And so that's essentially having multiple consumers with sharing the same subscription. So very typical in a cloud native kind of setting, right? In a cloud structure. So your topics can be delivered to different, essentially too, you have the producer producing to the same topic, and then they go to the different, kind of different consumer that subscription, subscription. Yeah. So again, well, shared is essentially you can share the same subscription between different consumers. Now, the fourth kind is that if you want the message delivery to preserve the order, so when it gets delivered and you want when it's being received, you want to have or actually when it's being published, you want to have the published order to be preserved on the receiving side. You can use this key shared kind of mode to do that for you too. So it will preserve the order of the message delivery for you. So these are the four different types of mode that it has too. So Okay. And now, then, why Pulsar? So again, I just wanted to kind of a quick kind of summary is that Pulsar is basically very flexible, and as you can see, right, the geo replication, the different subscription mode, and also the offset thing, it gets rid of the Kafka problem of the offset issue. That it has, right? So essentially, those are the kind of thing, and also separates the compute and the storage, and it's very flexible. It's really suited for the cloud native world that we're in. So here, then let me highlight a few Pulsar developer features. So first, if we kind of look into a data pipeline, right? So I wanted to highlight to kind of talk about Pulsar function. So essentially, too, if you think of data kind of travel through a data pipeline, you have the source like this, a faucet, kind of have water coming out the source, flows through the pipes, and then it gets into the Pulsar part, which is over here. It's essentially, as you can see, right, it does different things to the water that's flowing through it, the workflow. And basically, when it's all done with all the transformation, it output the transform data to a sink, right? We call it a sink. So it's think of like source and then transformer and then the sink. And that's how the data pipeline is, as we kind of talk about data pipeline. And then Pulsar functions in here, as you can see, you can have multiple topics to share the same Pulsar function as well. You have input messages, and then you pass it through some Pulsar function. And the thing is, too, the Pulsar function too can also output it to another topic, right? So a log topic is called. So essentially, it's for the logging messages too. So, or actually, I'm sorry, for logging, right? Essentially, logging of the message delivery. So you can also have that do an log output or output the message to another topic as well. So that's kind of Pulsar functions, and it's very lightweight. It allows for complex like streaming processing essentially, and it's like, and think of like function as a service, and that's what it is. And it's inspired by AWS Lambda, Google function, or AWS Azure function as well. So main languages again right now is only Java, Python, and Go, but there's also .NET and other languages being worked on to support Pulsar functions too. Okay, and then there's also this feature called Pulsar schema. Now, every time when we're doing asynchronous processing, right, the messages will have to go over the wire, right? They're like you have to serialize, right? If you're a Java programmer, you know that you need to flatten your structure, right, of some data structure before you send it over the wire. And then when it comes back, to the other side, and then it's basically you need to deserialize it, kind of reconstruct your object again. Now, it can be kind of cumbersome too if you have to deal with this serialization, deserialization yourself. You can do it, and then by default too, it needs to be essentially transform into a byte array before it can goes over the wire. Now, the thing is, there's also Pulsar schema feature. So this thing will allow you to basically define the schema of your data. And the nice thing about it is that your data structure can keep changing too. So then Pulsar schema can also keep track of the different versions of the schema for you. And the types that it supports, includes like primitive types, key value pairs, AFRO format, or JSON, or protobuf, or all kinds of data too. So it's quite kind of extensive in how the data types that it can support, and also supporting compatibility between different versions, the versioning of each version of your data schema as well. So think of it more like it helps you in when you're kind of doing kind of data transfer, that part, right, for serialization and deserialization. So. And then one more feature about Pulsar that I like to highlight, and there are actually other kinds of features, but I probably don't have enough time to talk about all of it. So I just want to point out, for example, in this Pulsar IO is essentially allows you to build your own connectors. Basically, you have source connector that kind of you can build, and then there's also sync too. So what is a sync, right? So think of the fact that you can have a source that comes in, right? You have the data that comes in into your system, your data pipeline. You kind of use Pulsar to do functions and transform it, any kind of mediation. And then when it's ready, it outputs it to a connect, to another connector, kind of to a sink, right? The sink too, at this point, they are pre-configured sink, right? For example, Kafka is already, if you need to output your data to Kafka, we already have a sink ready. And then there's also RabbitMQ, JDBC, for example, Ingress or Postgres, I'm sorry, JDBC Postgres sync, or JDBC MariaDB sync, or Elasticsearch sync, right? You can also kind of do another extra sync to Astra is our managed cloud platform. You can also do another sync, right, like that. So, for example, if you want to write it to some sync that isn't already there, you can actually use the Pulsar IO library and build your own customized connector as well. So it's pretty flexible. And now let me just really quickly to go over DataStax flavors of Pulsar too. So I work for a company DataStax, so we support Pulsar. Now the thing is too is if we are offering this cloud platform called Astra Streaming, so that's managed cloud platform. So the advantage of it is that you don't need to set up your Pulsar onto the cloud. Everything is already managed for you. All you need is just to sign on to the Astra streaming site, and then you can create your streams and create your tenants and do all sorts of things, set up your topics, right? Set up your syncs, all of these things. So I'll quickly show that to you in a little bit. That's called Managed Pulsar. And then there's also another kind of version of our not really so much version, is another kind of slightly kind of variations of how we kind of support Pulsar is through Luna streaming. So Luna streaming is essentially you host your own, you manage your own Pulsar in your cloud, right? Using Helm chart, for example, like Kubernetes, you have to deal all of it yourself, and you can actually purchase enterprise support from DataStax too, and we can also help support that for you. Now, the thing is, if you want to go completely open source, then of course you can also reach out to Apache Pulsar, download it, and then install it and run it maybe locally on-prem too as well. So very community-driven Pulsar too. So we all kind of support that, and DataStax would be happy to help you too with your whatever solutions you choose. Okay, and this one is just kind of point out, right? Pulsar is like the messaging substrate, right? We also have API layers that kind of help you kind of connect to things, right? There's Pulsar native, or there's also what we call API library called Starlight that you can connect to RabbitMQ or to Kafka or like to Starlight. Also, if you have older applications that are in Java messaging service JMS, we also support to Starlight. You can connect to JMS that are running in your system. So. And these are just some additional information to DataStax investment in streaming related products, right? So we can have on-prem, you can actually install your own and maybe run Luna streaming. And then there's also these features called change data capture, essentially for Cassandra, right? And if you're using Cassandra NoSQL, there are any kind of changes in your table, you want to capture those changes immediately, right? And do something about it. You can essentially use this feature called CDC for Cassandra too. So there's customer manage is your own run on-prem. You can use that. Or if you want to use our cloud, Astra Streaming is also Apache Pulsar as a service, right? You can do that. And we also have CDC on the cloud as well for you. So these are just additional information for you. You don't, you can choose and pick what you feel most comfortable with. So again, we have two, Luna Streaming and Astra Streaming. Luna is the one that you manage yourself and you can get support from us, or you can use our managed Astra Streaming. And also want to point out to you is that if you just want to play around with it, you can get an Astra Streaming, Astra Cloud platform and for free. And sign up for free, and you get $25 per month as a credit too. And don't worry about it; it will last you for more than a year. Actually, for up to a year for every month. We don't currently have any time limit for it. You do not need to give your credit card as well. So I'll quickly share that link with you shortly. And again, this one is just about how is Pulsar different from another messaging platform. I think I already talked about it, so I won't talk more about it now. But I want to now get to the point of doing the quick demo of Pulsar, right? So, all right, let me kind of just do this one thing, and this is Chicago. Okay, let me actually here. Okay, so actually, you know what? I should have done it, but I didn't do it ahead of time, so it's my fault. Let me bring up my over here. Let me bring this up over here. Okay, and all right. So you can also follow too, right? So you go to Astra, astra.datastacks.com. And so now you'll see that we have this free sign up for Extra DB. This is the cloud platform that you can run Apache manage Apache Cassandra on. So now the thing is, for you to sign up, you can use your GitHub account or sign in with a Google account, and you can sign up here if you haven't already done so, if you like, or you can just. In my case, I've already signed up. So let's say, right, if I sign up, then it's basically you give your first name, last name, your email address, and give a password, and then you can create it. Look at how easy it is without you giving your credit card, and that's what I like about it. But in this particular case, let me see. I already have an account, so I won't do that. I'll just go back to extra.database.com and I do a sign in. And once you sign in, you notice that it is quite easy to kind of jump start on working with Pulsar. So in this case, it also gives you a dashboard. And if you want to play around with Cassandra, it's also here. You can just say create database. Let me kind of increase the font a little bit. So you can actually play around with the database. In my case, I already created some database. And then streaming is what we're looking at. So I can just do a create stream. And then remember the tenants I talk about. You can create something like Jack's Jug, for example. I call this tenant, and then I would say I want to do US East 1 for Google Cloud. And then as you can see, it tells you how much it would cost, pay as you go, right? So create tenant. And here is actually quite enough. If you're just doing experiment for a whole month, $25 is plenty sufficient too. But in my case, I already have some tenants, so I won't go and create it. But if you are interested, you can follow along and create a tenant. But let's see what happens once you create a tenant. So I'm going to go to another organization. It's called DataStax Swim. I already have my a stream created called POC tenant. So over here, once you have created your stream, then it will show you like quick start. It will guide you through what you can do with it. You can create a topic and then produce data and using Java, Python, Golang, Node.js, all these things. And then how do you consume data? You can also click on these to take a look and then confirm the data flowing too. You can basically do the monitoring all within this interface too. That's quick start. And then if you want to kind of take a look, and get all of your connection information, this will actually give you all of your broker service URL. Web service URL is for admin interface. We also have Pulsar client on the command line or Pulsar admin too on the command line. And also you can see too for the admin interface, we're using HTTP for the admin. Or you can also use WebSocket URL too. But as you can see too, for the broker, anytime your client communicates, we're currently only supporting like Pulsar and SSL connection right now. So that's how you do it. And also too, if you want to kind of take a look, how do I, write Java code? You click on the Java side and it gives you the information on Maven and Gradle. And then how do you write a producer? We also have a very simple producer already in place. As you can see, this is just, the most basic form. You can just, provide it, your service URL to it. And as you can see, that's a Pulsar plus SSL kind of a service URL. And basically in your main, as you can see, all you need to do is first connect to your Pulsar client, right? Give the authentication, all of these things. Again, all of this information too, you can basically download. Oh, okay. Go back to quick start. Wait, actually go back to connect. Connect will have this thing called download a client.conf. So the client.conf already give you all of your authentication, token, and also your connection URL, everything too. So you can kind of find things from there. But again, let's go back to the Java side. You want to do producer. So over here, you do a client connect and then do the producer, new producer, and then you can do, producer tied to a topic, and then you can then you essentially establish connection to the topic. And then when you're ready, you can do a send. And then the send, remember I mentioned about I'm not using Pulsar schema. Then you basically have to do the string and doing a get bytes that will convert it to byte array. Then you can then send the messages over to the topic. And then everything then at that point will be handled by your broker for you. And then you can then safely say when you're done, you can close it and your client close. Now on the consumer side, also it's kind of think of it like that is also similar. You just do a client build, essentially establish your client, right? Set up your client first, and then basically then set up your consumer, and then attach it to a topic, and then also then specify the subscription name. And then if you don't specify it, I believe that is a just a shared mode subscription. But you can remember, you can do exclusive mode, you can do failover mode, or doing key share mode as well. And then at that point, then once you kind of establish your subscriber, is essentially you're just waiting in there, right? You do a loop, you wait for there. So once there are messages arriving, then you'll be receiving in here. You can then do a system out printf, and then you can then print out your data, and then you can acknowledge it. Once you acknowledge it, you're telling Pulsar that it can be removed from your system essentially. So, and then when you're done, you can then do a consumer close and client close. Now, another interface I mentioned about is you can use this reader interface. Reader interface allow you to kind of traverse, into attached to your log messages and read it, to kind of navigate through it using the cursor. All of these things can be done through the reader interface as well. So, okay, so that's kind of a very quick run through of what this is. But let me then go back to our here. Let me hold on a second. Sorry. Let me kind of bring this back over here. And then I can then continue with this demo. And again, or not demo, with the slide. So, let me see. Okay, here we go. Go back. So I just kind of quickly show you some kind of information on how you can start with Pulsar. But let's say you want to continue kind of invest in, kind of learn more about it. So here are some resources, right? How you can kind of learn more about it. It's on pulsar.apache.org, or the bookkeeper, zookeeper, and then also how do you sign up for the Astra database, the cloud platform is here, astra.datastacks.com, and then all of the information, the documentation too, on DataStax website, on Astra streaming, on Lunar streaming, or for the change data capture for Astra DB. And then also too, wanting to bring to your attention, if you want additional credit, you can get like $200 in credits to using this link and using this code open source 200. Also, too, we have some 5 minutes about Pulsar on YouTube too, that you can also check it out. We are constantly producing these little short clips. So if you want to get a quick understanding of some concepts, for example, like how do you do a Pulsar function, what is a topic, things like that, we will be explaining that for you on our YouTube channel. And it's actually the DataStax developers channel. There's a playlist you can search for 5 minutes about Pulsar. And then I mentioned about my Twitch stream every Wednesday, usually at 2 p.m. But for this week, I'm doing it tomorrow. So this is my Twitch URL if you want to follow me there. And then also, if you want to start coding, right, all of these are just so much information. We actually, on our developer advocacy team, we have an awesome Astra website too. So this is the link to it. It's essentially a GitHub page, but we explain, how do you start coding? We give you a lot of guidelines to just jumpstart your journey into our Astra platform too. So check it out. There's also Cassandra and different things too in there, not just Pulsar, but Cassandra and all kinds of, our integration with other third-party software. Even like with Kafka, for example, you want to know, you can check out awesome Astra. And then there's also some sites too. For meetup.com is the Apache Pulsar Neighborhood, meetup.com page, and also Apache Pulsar Neighborhood, the wiki page that you can look for more information, or you can contribute to it too. And then with that, I want to thank you, and thank you so much again for having spent your Tuesday, or actually, no, this is not Tuesday. This is what, Wednesday, I'm sorry, Wednesday with me and spending your time with me. So I want to thank you for that. And with that, kind of hand back to Eyal. I hope I'm not going over time. So thank you. Yeah.
You're doing fine. That was a very nice presentation. I really
Thank
enjoyed
you.
it.
Thank you. I hope it is helpful. Or if you have questions, please feel free to ask now or later, right? Connect with me. Again, you can follow me on Twitter, on LinkedIn, or my Discord server too. You can ask questions there later. Doesn't have to be now. So yeah, or you can share with me your projects too. Sometimes I think folks have projects you're working on. You can share with me too. And then also, I may be learning from you some of your projects that you're doing. And yeah, and you're expert in what you do. So yeah, so I'll learn from you too. So thank you.
Thank you everybody for joining us here, and thank you very much, Mary. Oh, I
Thank
see.
you.
It's not a question; it's another
Oh,
response.
there you go. Thank you, Taigo. Thank you. Thank you. Yeah. Best way to connect with Pulsar is using functions. Actually, you know what? You talk about how to connect with Pulsar. The thing is, understand like functions are kind of, it helps you to transform your messages. So the way you do your Pulsar is you always have it like using the PubSub, because Pulsar is a PubSub architecture. And so you basically want to, if you want to produce data, right, you have to write your own client as producing client, or you are subscribing to some topics, right, and you can do that too. So basically, to connect to it, you need to either as a producer or as a subscriber, and then you use functions to transform the data that you get from a source, for example. So yeah, so yeah, I hope it helps you, Diego. So yeah. Okay, good. And connect with me on my Discord and feel free to share with me your projects too. I would love to hear from you too. So yeah. And thank you, Andres, too. Thank you very much. Thank you. Thank you, everybody, so much. Thank you, Eyal. Thank you.
It's
So
a great pleasure to have you here.